Read me out a question and we'll go through it then.
Okay. 10x equals 500.
10 to the power of x equals 500.
Yes.
So that's in exponential form because the unknown is the exponent. So you want to write it in logarithmic form, yeah? Does anyone know already? Ethan.
10 log base x 500. No.
No, not quite. Karen.
Is it log to the 10 equals 5?
You've
Sorry,
forgotten.
log 10 500.
Log 500.
Log to the base 10 of 500.
Log to the base 10 because this is the 10 is the base of the exponential form. So we have log to the base 10 of 500 equals the x. Okay. Now that's the base. That's why we have log to the base 10. But what do we know about log to the base 10, the way we write it?
Just log.
Just log. What were you going to say, Tim? Something else. Yeah, we don't use a 10. We do for any other base, but when it's just log to the base 10, we can just write log of 500 is x. Right, now I just want to check something. Let's say if you had to solve that without a calculator now, how could we go about doing it? So this is practicing our laws.
It will be 500 divided by 10.
Why?
Because it's in the base 10. No, no.
Well, so actually, I'm going to go through it because I don't know whether it's actually going to be what we would want to do. But just to check the laws that we were talking about before, I'm going to change this to log to the base 10 of 5, add what? 100. Does everyone get why I can do that? What law have I done?
Multiplication.
Because that's 5 times 100. So I've kind of done the opposite of what we were talking about before, which is say, right, if I've got something times something, I can split them to be adding. The log to the base 10 of 5, well, that's still as it is. But I could write this as log to the base 10 of 10 squared. Yeah. Which would then be log to the base 10 of 5 plus what? 2 log to the base 10 of 10, which would be the same as, so log to base 5 plus,
Log.
well, what did we say? If we've got a log to the base 10 of 10, if it's log, it's not, no. Log to the base A of A is always 1. Because remember, the opposite is saying A to the power of 1 equals A, which is the exponential forms. So I can actually write here now just log to the base 5 plus 2. Okay? Which you can see doesn't actually give me any better answer than I had before, but it does, we are practicing with how we can split it up. Okay? But that tells me how to go from exponential form to logarithmic form. Log to the base 500 equals x, which I can manipulate if I want. Remember that? Yeah? No? This is difficult. Difficult crowd. Any other question you want to go through first? Have a look through the whole thing and pick an example where you think, oh, I might not be able to do that when I get there. Let's ask it now. Yeah?
Log to the base x, y.
X of y.
X of y equals
0. Okay. And what do we have to do? No, what's the question? What's it asking us to do? Write it as...
Write down an equivalent exponential statement for...
Write down an equivalent exponential statement. Right.
Oh, so that would just be
x to the 0 equals y.
And that would just be y.
So y equals 1 is something we can state. Now that's another important statement actually that they're asking you to see, is that if you've got log to the base anything of what? 1 will always equal 0. Doesn't matter what the base is, log to any base of 1 will always equal 0. Okay. That's quite an important one. Is there any others that you'd like to go through quickly now? You look all the way through, you have a quick scan and go, oh yeah, fine.
Oh, we're not doing 3, are we? Oh, yes, we are.
You can whole thing and over the page as well, and the problem solving and
Oh, okay.
Ethan?
Log
Sorry, hang on. Log log to the base b of b equals 4. Okay. So I've got to write what? Got to write it as an exponential. Okay. What would you do?
log.
Well, if it's going to be exponential, it won't have a log. Remember, this is why I say it correctly. Because how do I say that statement? Log to the base b of b equals 4. So how do I write the exponential? So b to the power of 4 equals b. So just to be sure, this b is that b. Remember, you're using logarithms or exponents to change the focus of the statement. So if we've got that, log to the base b of b equals 4, what do you know about b?
B equals...
Something to the power of 4 equals itself.
Wait, wouldn't log to the base b of b equal b?
Well, there's 3 b's then though. Where did the 4 go?
No, just on that side of the equation. Because it wouldn't be the same thing as like log to the base 10 of 10.
Yeah,
So it would just be b equals 4.
b equals 4. No.
B equals 1.
b does equal 1. Because the thing is, we're not saying this one is not, yeah, b is equal to 4. But I see what you're saying, because if we did log to the base 6 of 6 equals so what are we saying? If we said that was x, we're then saying
it would be
6 to the power of
x.
x equals 6.
Oh.
So So that would make x equal to 1. Okay, but we've got a different statement here. We're saying it equals 4. So there's that leads us to that situation where b is 1. Why would that one be a little bit confusing? Why does that not fit the pattern that we were looking at before of log to the base itself of itself equaling 1? Why is it not quite the same? So as I think Kieran was thinking back to something else we've said, which is good, we said, but if it's log to the base 10 of 10, he was saying the answer is 1, and if it's log to the base 6 of 6, the answer is 1. Okay? Well, what's log to the base 1 of 1? 1. Log to the base 1 of 1, which is what I'm saying here. Log to the base 1 of 1 is 1, but can it also be 4? And the reason is because 1 is the only number that you can raise to any power and get the same answer, yeah? Anything else doesn't work, because 6 to the power of 6, you know 6 to the power of something equaling 6 has to be 1. So that leads us to this question.
So log to anything, like
log to the base.
Log to the base anything of the same
of itself.
Always equals 1.
Always equal 1, apart from 1 or 0 is something to discuss. But is that leads us to another question. 1 to the power of x equals 1. Is it possible to solve that exponential equation?
No, it's a math error.
1 to the 0.
It could be 1 to any positive integer.
It could, yeah.
It could be anything.
No, it couldn't be a decimal.
Couldn't be a decimal.
Why not?
Because that wouldn't be whole.
Okay, 1 point. What about negatives?
It could be anything.
It would give you a fraction.
Fraction or like.
But it could be a whole negative.
It
But
was-
would it be all
still-
whole
It would
negatives?
still give you a fraction.
Would it?
If it was negative, it was divided by negative.
1 to the power of
Negative,
negative 3.
1 to the power of.
That would give you a fraction.
It would give you a fraction. Good.
Yeah, it would give you
Yeah.
a fraction, but it would be an improper
It's
fraction.
because a lot of people would say, that's fine, because that'd be negative 1, wouldn't it? Because they're getting confused with negative 1 to the power of 3 is negative 1. You now know that negative 1 to the negative 3 is not negative 1. That, as you would say, is 1
1/3.
over
1 over 3. No, 1.
equals.
Oh my god. Why did I think it was 1?
But it isn't negative 1 to the negative 3. It's just 1 to the negative
1 to that, which is a fraction, like you said, but it's a fraction where the numerator is 1 and the denominator is always going to be 1. So what can I raise 1 to get the answer 1?
Anything but a decimal.
No, you can't raise it to decimal.
Well, let's have a look. What about 1 to the power of a half?
Because the square root of 1 is 1. Because 1 times anything.
Yeah, but what about the
1
quarter?
times 1 times 1 times 1 is still
That's
equal
a
1.
fourth root, which is still 1.
Therefore, 1 to the power of negative 0.632 is 1. So this is one of those equations. X can equal any number you like.
That's why if you put that log to the base 1 to times or 1.
Yes, exactly. That's why this case, which is right, I'm glad Kieran had that thought. It's like, but hang on, that's not really fitting. If log to the base something of itself equals anything other than 1, it must be, b must be 1, right? So you can, So so this is good to understand. Stop. Right. So for instance, if I said to you, log to the base x of x equals 1, what could you tell me?
X could be 10. Oh, X is any number.
X can be anything, okay?
X is anything and everything.
So x could be any number in that case. However, if I change it slightly and I say log to the base x of x equals 15, x has to equal 1. So x, if I write this, x can be an element of any real number. Do you recognise that? Have you seen that before?
Yes.
Yeah? But this one, if I change this away from, so if I said, get rid of that and call it y, but I say y is not equal to 1, then x has to be 1. Because it's the only thing that can work in that situation.
So how is log to the base 1 to 1, 15?
Because what would that be telling me? That would be telling me 1 to the power of 15 equals 1.
Oh, so 1. Okay.
1, if I change it to y, 1 to the power of y equals 1, because we've already discussed that that's always going to happen no matter what it
Okay.
is.
So you could do like log 1 to 1 equals anything.
Exactly. But if I do log to the base x of x equals 1, well, x can be any number I like. Yeah?
Could it be a number that you don't like?
Could be a number that you don't love,
You said a number that you love.
like.
Any number that you like. So,
What if I don't like it? Well,
Yeah.
it can be that as well.
it's interesting.
It is interesting. Happy numbers and all that. Okay, any other particular question you want to go through from the book before I let you carry on?
Log to the base 8 for
Log to the base 8 of 4. Should we start saying?
of 4 equals 2/3.
2/3. Okay. And what have we got to do? Exponential 4. Okay.
Ooh,
Log, sorry, no.
8 to 2/3 is 4.
So 8 to the power of 2/3 equals 4.
Oh yeah, that makes sense.
Yeah, makes sense.
1/8.
1
Now,
to 8.
I should now be able to ask you to prove that statement's true
Yes, I can do that.
by putting it in the same base. Can you do that?
Oh, I'm putting it in the same base. Even better. I don't think.
Well.
What I would do is cube root 8,
Yeah,
and then power 2. Cube root 8 is 2.
yeah,
And 2 squared
is 4. Yeah. Could anyone do it by putting it into the same base? Both sides to show they're exactly the same. So if I give you a clue and say, what's the common base going to be between 8 and 4? 2. So if I say 4 is 2 squared,
8 is 2 cubed.
8 is 2 cubed to the power of 2/3.
Oh, and then we cancel out the 3's.
Oh,
That multiplies to make 2 to the power of 2 equals 2 to the power of 2. So combining our knowledge that we have. Okay? Nick wants to shout out for this really poor channel. Go on.
No. I was just gonna do your outro. Okay. Anyways, guys, if you enjoyed this mathematical video, hope you guys just leave a like down below. Don't forget to comment what math help you need next, and share with your friends. Hit that big red rectangle for more, and the bell if you want to stay tuned for the videos. I'll see you guys in the next video. Thanks.
So looking at these two, one's a question from the book, one I've made up.
Log to the 16th divided by log to the
So these are different questions. So it's question 1, question 2, separate. So we've got to solve for x, and we've got to be able to do it without a calculator. So when it's a logarithmic one, it's not always that we want to put it in logarithmic form to solve it, because that's when we've got a calculator. For this one, how would I rewrite it in exponential form? Nick?
You would write it as 2 to the x equals 16.
Okay. Now this would be nice and easy, because you now know that x is 4. Okay. Another way to do this, by the way, is to say this. We've got log to the base 2, and because base 2 is the base, I'm going to write that 16 is 2 to the power of 4 equals x. How do you feel about that?
Then you just cancel the 2's.
Well, what do we use? So then the power becomes a multiplier, and it becomes 4 times log to the base 2 of 2. Log to the base 2 of 2 is 1. So we end up with 4 times 1 is x, which is 4.
We might have answered this question already, but what does log actually do?
Log is the inverse of raising something to the power. So you notice you have rewritten log to the base 2 of 16 as 2 to the power of x of 16. It's the inverse of it.
Yeah, but
It's a different way of writing exponents.
Yeah, well, it's like...
But exponents are like easily explainable, like 2 times 2 times 2.
But I fully accept in this case, that's what we can. But do you remember we talked about what if x was going to be a decimal that you could never find? 2 to the power of 1.28.
Yeah.
It's not easily explainable. So really, logarithms that we have to do the logarithm, we probably have to use our calculator.
Mm-hmm.
What about this one? If I asked you to do it this way for me, what would you say? Got log to the base 2 of
2 to the 4. I mean 2 to the 3.
2 to the power of 3,
So
which becomes
x equals 3.
so 3 times log to the base 2 of 2. So x equals 3 because that equals 1. Okay. So that's by simplifying the logarithmic one, or the other way to do it is, like you said, convert it into an exponential form and then you just do it because you know it. Yeah.
So the exponential form of that would be 2 to the power of x equals 8.
Exactly. Yeah. Which you solve that just because you know that 2 to the power of 3 is 8. Okay. Make sense? Right. What we're going to do next lesson, we're going to have a look at the natural logarithm. And E, ln and E. So I want to talk about that. Do you have any pre-reading to be done?